Okay, folks, tonight we have a fairly strange problem. We're looking for a value of s, and s is the coefficient of x in this cubic polynomial, such that s is greater than 1. Now, it seems a little strange, and I worded it carefully. There's more than one. I didn't put the value, I put a value. Now, note, this doesn't take long to compute. If x is equal to 1, if you put x equals 1, substitute it, evaluate the polynomial at x, you will get that s is equal to 363. And again, that's a fairly easy computation. But we're looking for something that's non-trivial. We're looking for a value of s, an integer that's greater than 1, but we want it to be something easier than just substituting 1, because that's an easy computation, okay? So let's see if there are others. We know there's 1. We've already answered the question, in fact, but let's see if we can find others. All right. So we'll start out with the standard sort of approach here used in Vietas. We'll let a, b, and c be the roots. Now, these are real values, a priori real values, not necessarily integers. So if they're the roots of this given cubic polynomial, they induce linear factors. You see right here we have a is 0, x minus a factor, b is 0, x minus b a factor, c is 0, x minus c a factor. I call root and 0 the same thing. Now, when you expand this out, this is an expansion. This is what happens. The negative sum of the roots pile up in front of the x squared term, and then all these pairwise products occur in front of x, and then finally the product of the roots occur as the constant term, which is very easy to see. These minus signs, one of the minus signs sticks around, right? An odd number of minus signs. So this is the expansion when you substitute the roots in. I could put equals to 0 right here. It's not really necessary. What we can do is notice that minus 21 is the coefficient in the given equation, right? Minus 21, so we can set it equal to minus a plus b plus c, because minus a plus b plus c is the coefficient of x squared. This is called Vieta's formulas, but you can just multiply it out every time and see what's going on. You don't have to remember the formulas themselves. And also minus 343 is equal to minus ABC. Here's the minus 343, and we just physically set it equal to minus ABC. And of course, you can see the minus signs will cancel, and this is how these things work. The signs alternate in Vieta, but you can, if you just write it out, you can just see what's going on. Now let's see, what can we do here? We have two equations, three unknowns, but notice the minus signs will cancel here, and I want to write down a result for you here that probably looks familiar, and some of you may have already guessed the answer, but notice that a plus b plus c divided by 3. Remember, a plus b plus c is just going to be 21, right? So divided by 3 is going to be equal to 21 over 3 equals to 7. Now, a lot of you guys may recognize this as the the arithmetic mean. Y'all, this is the arithmetic mean. That's sometimes called AM, not anti-meridian, but arithmetic mean. All right. So this is the arithmetic mean of the three zeros. Wait, what? Sorry. Did I screw that up? Erase. Divided by 3 is equal to 7. Sorry about that. Okay. And again, y'all, this is called the arithmetic mean. You sum up the three values, divide by 3, and that's called the arithmetic mean, or the good old-fashioned mean. Now over here, ABC is equal to 343, that what they call the geometric mean. You take the cube root. You don't divide by 3, but you take the cube root. Okay, and you get 7. Okay, now notice they're the same, and the arithmetic mean, geometric mean, inequality. Let me write this down a little more carefully. We'll call this the geometric mean. It's very well known that the arithmetic mean is greater than the geometric mean, greater than or equal to. Is greater than or equal to the geometric mean. And the equality happens when all the values are the same. All the inputs are the same. So in other words, what we know is that equality occurs. Equality occurs, and we do have equality here, right? This is the arithmetic mean. It's equal to 7. We have the geometric mean. It's equal to 7. So the equality occurs when all three of these values are the same, but that implies that A equals B equals C equals 7, right, folks? Again, we're using some AMGM logic here. Arithmetic mean is typically larger, all right? But the equality does happen when the inputs, that is, the inputs in this case are A, B, and C are equal, and so that would force A equals B equals C equals 7. No two ways about that, right? Okay, and so again, notice that 7 cubed is 343. Let me write it right up here. 7 cubed is equal to 343. Well, we know that, right? It's no need to write that down, I suppose. But so what does that tell us? Well, let's come back up here. We're looking for S, right? So S is located right here, right? These AB plus AC plus BC is equal to S. But notice that that's going to equal to 7 times 7 plus 7 times 7 plus 7 times 7, because all the inputs are the same, all the values are the same, namely 7. But what does that equal to? That's equal to 3 times, that's 49, right? 49, 49. So if you want to, we can write that as 3 times 7 squared. And that's equal to, is that 147? 147. Yeah, that's what I got for the answer, 147. So what we have figured out using what they call AMGM logic, and you can just kind of identify if you knew the answers are integers, you know, you could tell that's the answer. So it's not, the AMGM may not be strictly necessary here. Just by inspection, you could have figured it out, right? So not that big a deal. But in any event, what we have learned here is that when X is equal to 7, that implies that S is equal to 147. Okay, so that's the final answer. Now, y'all, again, not a particular, at this stage, a lot of you probably just looked at it and go, oh, I know the answer. You know, A plus B plus C has to equal to 7. You know, just like that, you know, because 7 times 7 times 7 is 343. So maybe it was, strictly speaking, unnecessary to use the AMGM. I think, though, there's real solutions to this, you know, that are, you know, 777 is obvious, and that's the way the question was asked. You could have just answered it without going through this AMGM. But it's kind of nice to see this inequality getting used at the equality condition. The only time equality occurs is if A equals B equals C. So in any event, maybe it's a little bit overkill using AMGM, but in any event, we got the answer, I guess, in more than one way. Okay, thank you for viewing.